Good morning. Okay, how we do it? Basically, we mimic the process by which crude oil is formed in the Earth's temperature and pressure. And instead of waiting for millions of years, we do it in 20 minutes. So that's the science and technology behind it. Pressure, temperature, and electrochemistry. And let me give you some background. How was my involvement in the project? Ellie got a grant from National Science Foundation last 4 years actually, 2008, 2012. Around $2 million to work on the basic research. And she completed the project and reported to NSF. As you know, NSF, they do not support any business-related or commercialization projects. So they're under pressure to show that what they support using taxpayer dollars, they can generate some revenue in terms of new products that the industry is looking to use those products. So they initiated this program called Innovation Corporation. And the purpose is to fund those previously completed NSF projects that have potential to be commercialized. So how it worked, after Ellie submitted the proposal and the result was completed, I joined the team with her student as 3 members, as a corporation. So 2 individuals from more technical background, and I was a person to help them with the business side. And we submitted that proposal, just $50,000. And there were around 300 applications and proposals, and we were one of 27 to be nominated. So you see, it's very, very competitive procedure. The NSF project itself, not the Innovation Corporation, those typical NSF projects are very competitive, 10% submission acceptance rate. And this on top of that one. So we went through lots of discussions, interviews 3 times with professionals in industry and NSF officials. So that was how this project formed, came out of the lab and to the industry. So what we did here, we basically talked to customers, asphalt manufacturers, asphalt building terminals, paving companies, roofing, ceilings, just talking to them, do you really want to use this product? Okay. Actually, it was interesting. When we received the award notice, it was something set in a red line that this is not a lab test. You need to get out of your building and talk to your customers in a red to make sure it's not something that you did in your previous research just to sit in lab and do tests. You need to get out of the building and talk to the customers. So that was the purpose of this project. So here we talked to around 122 customers within 3 months. It was very, intensive program. We were required to talk to 5 customers the first day of that program. So they just pushed us to do more and more. And still we are doing that, honestly. We are just doing the same program as we are speaking today. And the technology is patented. Actually, it is patented by the university. As you know, when you receive federal grants and you develop patents, that's the law that the university holds the patent. But as an inventor, we receive the first right to refuse or accept the licensing from the patent. So we have European and US patent pending, and Bio-Adhesive Alliance has exclusive right to practice this technology worldwide. And we have some partners in France, in Europe, in Chile and China. They are very, very interested to license it and practice this technology. Just, I show you some numbers in each region, how large is the market for this technology. In the US, we have roughly 6 billion gallons of soy manure each year, and that converts to 88 million barrels of adhesive. When you look at Europe, it's the same size, and looking at China, it's 5 times more of the US. So you see a huge market here if you can use all those resources and convert that to Bio-Adhesive. Okay. When you come to the business side, you need to compete with other companies. And as you see in the left side, These are oil and gas companies. I mean, the major source of adhesive are oil and gas companies. As you see, those are located in the outskirts of the US. To the right side, you see hog farmers. And as you see here, those are kind of located from east, Midwest, and to the west side. So in terms of transportation, okay, it's much easier to access this area, and you can save on the transportation cost. So that gives us what we call competitive advantage. Compared to our competitors, we get advantage in terms of location and transportation. Okay. So I mentioned that we compete with major oil and gas companies. At the beginning, we thought they were large, and it's very difficult to compete with them, but we found interesting finding when we talked to them. Actually, as you see here, the barrel of crude oil, and this is 50% gasoline and other components, and what is left, 10%, they use for asphalt. Because for the last 40, 60 years, they didn't know how to use it, so just use as asphalt. What's happening, they have developed technologies to convert that 10% to synthetic fuel, and that's more valuable for asphalt for oil and gas companies. So what's happening, we are seeing less and less supply from the oil and gas companies in proportion to other products, since they're converting at 10% more and more to fuel, synthetic fuel. So right now, the number I have is 4 or 5%. So actually, we assume we are competing with them, but we found that we are complementing them, because they can use more of those 10% residue to create synthetic fuel, and then we can replace that product.